I still remember the day I nervously presented my boss with a PowerPoint I had been working on for weeks. After my presentation, my boss asked, "Can you be more creative?" I was taken aback, unsure what they meant by creative, but assured them that I could anyway because I didn't know what to say. That moment was a catalyst that led me to dive deeper into understanding creativity. Hi everyone, my name is Cheoh. I'm a PhD candidate and a creativity researcher at Purdue University. It's really a pleasure and privilege to be here. Today we will explore the topic modeling creative processes with a generalized additive model. With the emergence of human-machine intelligence, the concept of creativity comes up and has been widely debated. Some scholars argue that machines like AI destroys creativity, whereas some scholars argue that it leads to more creativity. My research seeks to understand these dynamics through the mechanism of creativity. As creativity scholars, we know that the consensus of creativity in the literature is that creativity is novel and useful. But what leads to the creative product that is novel and useful? It is the mechanism in the creative process called search. Using search, we go on an adventure hunting for ideas, and we interact with ideas that ultimately form a landscape in our mind. You may ask, what is a landscape? Search takes place in the mental landscape. The mind is like a landscape, where ideas are seeds that can be cultivated and explored. Newell and Simon in 1972 had previously theorized search as the process of navigating our mental landscape to perform complex tasks and make decisions. In other words, search means charting our mental terrain to leverage past experiences and knowledge in order to come up with new solutions. But the search that occurs in the creative processes is hidden in the human mind. How do we create an experiment to give us the signs to see the processes of creativity? This is where the magic and brilliance of this research comes in. Remember the saying, Rome wasn't built in a day? First, we have the skeleton of the building, then the structure of the building, and finally the window in the building. I realized that I can capture the variations of the artifacts in each iteration that allows me to capture the signs of the processes of creativity. In other words, the dissimilarity of the artifacts in each iteration gives me the measurable distance of search that I can use to understand the processes of creativity in a measurable way. The question is, in the complex tasks like building a tower, what do the search processes look like? Louis Sullivan, an American architect whose famous phrase in 1896 form follows function, hints at the presence of two such processes. Do we think about form, how something looks, before function, how something works, like Louis Sullivan claimed? The question that I'm interested in answering is, how do humans' cognitive search patterns look in complex tasks? In other words, how do I capture the evidence that humans use more than one search processes in complex tasks? This is an important question to answer because according to George Miller, a psychologist, humans have limited information processing capacity, which means that we tend to prioritize certain information in our mind when solving problems. The hypothesis that I'm interested in testing with Generalized Additive Model (GAM) is designers employed varied search patterns across the distinct parts of the created artifacts. So in this experiment, I recruit 108 senior software engineering students to to help me answer this question. The complex task that is assigned to these software engineering students is to design web applications to help their classmates to find safe and affordable places to rent surrounding their university campuses. The software engineering students are required to make 5 submissions across 30 days. The variations between submission 1 and 2, 2 and 3, 3 and 4, 4 and 5 are considered, which means that there are 4 stages to study. The next step is, in each of these 5 submissions, the non-visual and visual components of the web applications are extracted with computational methods. Why do I categorize the search spaces into visual and non-visual components? It is because scholars have previously noted that there are 2 such processes when architects produce their designs through think-aloud methods, which are visual and non-visual. However, I'm curious about 2 things. First, do these hold when engineers working on digital artifacts like web applications? Second, how can we see the evidence that there are at least 2 such processes? I measure the similarity between the non-visual components and the visual components themselves to capture the variations between the submissions. Then I take 1 minus similarity as the distance of search between 2 individual components submitted by a student in submission 2 and 3, which forms the distance of search for the second stage. Later, I realized that, oh no, search in the creative processes is non-linear. We don't think linearly when trying to come up with ideas for complex problems. What do? This is where the use of Generalized Additive Model GAM comes in to account for the non-linearity in search. A Generalized Additive Model GAM is a flexible statistical model that uses smooth functions such as splines to capture complex non-linear relationships between the predictor and the outcome variables, as illustrated by the red line fitting the blue data points on the graph. The dependent variable is the distance of search, ranging from a scale of 0 to 1. The GAM includes a smooth term for the stage variable to capture potential nonlinear relationships. Essentially, this means that the model can better represent complex patterns in the data that a simple linear approach might miss. The by argument allows the smooth term to vary by the type of search spaces, whether visual or non-visual search spaces, essentially capturing the variability introduced by different types of search spaces across time. When I interviewed participants what the processes of creating their web applications were like, one participant suggests that they started on the front end before working on the back end. The response shows that the time factor is at play during the creative processes, and that because of the information processing limitation of our mind, we prioritize certain information when solving complex problems. I found that the search patterns are distinct between the non-visual source code functions and the visual components, the layout of the web applications. The plot applies the logistic transformations to the predictions, which constitutes the values on the y-axis of the plot. The logistic transformation is used because the model employs a beta regression with a logic link function as indicated by the blue wordings. This transformation ensures that the predictions are mapped onto a scale between 0 and 1, which is appropriate for the proportion data like distance of search, and then shifting them by the intercept value for clearer interpretations as indicated by the orange wordings. The green shading is used to represent confidence intervals. Another interesting finding is that between the non-visual components, I found that the search patterns are distinct between the source code functions and the dataset used as well. The results suggest that there are more than 1 or 2 search processes in complex tasks, and that the processes is more complex than I initially thought. Lastly, between the visual components, I also found that the search patterns are distinct between maps, charts, the background, and the overall layout. The results indicates a more intricate interplay of such strategies that are context-dependent, varying with the type of visual component and possibly the user goals and cognitive load. This complexity in such behavior highlights the need for a more nuanced understanding of how individuals process information. The inference is that designers do not just traverse a single search space when engaging in complex tasks like designing a web application, and designers prioritize specific search spaces at distinct stages. This finding aligns with a broader understanding that creativity in product innovation requires examination from multifaceted perspectives to uncover innovative solutions. Reflecting on the day my boss asked me to be more creative, I realized that this seemingly simple request pushes me to explore creativity as a process to be studied and defined. This research has implications on the science of creativity. It means that future researchers must carefully define the operative search spaces at each stage when examining instances of creative problem solving. Just as I had to understand what creative meant in that moment, so too must we define and understand the parameters within which creativity operates. I would like to acknowledge these wonderful mentors who have provided feedback on this presentation. Thank you very much for listening to my presentation today. I hope that my presentation will contribute to future creativity research that allows humans to think faster, better, and achieve more.